Now you might be thinking, well, that's an interesting derivation of a call option on a zero coupon bond, but if you've worked in the markets, you might comment that call options on zero coupon bonds don't seem to be a very popular instrument. So what good is this? And what we're going to see in just a moment is a popular interest rate based option in the market, in particular a cap or a caplet, which is really an option on interest rates, can be redefined basically as a put option on zero coupon bonds. So the importance of this call formula is not that one needs to trade call options on zero coupon bonds. The importance of it is that this call formula, we'll see, will give us the price of a put on the same zero through put-call parity, and that put option is equivalent to a call on interest rates, and that's what caps and caplets are. So we'll start with a review of so-called forward rate agreements, just to remind you how those work. So let's let R0, T plus S, denote today, time zero's forward rate for the period T plus S. So here we are, time zero, and we're looking ahead to the period T plus S, and we're observing what's the forward rate. In that, we can calculate that forward rate by using the price of zero bonds today. It's a simple exercise I'll leave to you, but we can these forward rates are observable by virtue of the spot rates today, which are observable by zero coupon bond prices. So if we wanted to talk about an S period forward rate agreement at time zero that has a payoff at time T plus S, it has a payoff defined as follows, that the payoff of this contract, and this payoff can be positive or negative, it's not an option, so let's keep that in mind. The payoff of a forward rate agreement is the difference between the spot rate that prevails at time capital T for the period T to T plus S and the forward rate. So basically what a forward rate agreement does is provide a payment or requires a payment that's equal to difference between the prevailing spot rate at time capital T and the predicted spot rate, which is the forward rate, as of time zero. That's what a forward rate does, forward rate agreement does. A forward rate agreement can also be paid off at the beginning of the period by taking a present value. The usual convention is that the forward rate agreement pays off at the end of the period, this difference in interest rates. But one can always take a payment at the end of the period and synthetically or by various trades convert it to a payment at the beginning of the period equal to the present value of that. And so if we desired a payment at the beginning of that period of time capital T, we would take the present value of that payoff. And again, note, this payoff can be positive or negative. It is not an option. Now, an FRA can be used as a rate hedge. And let's see why. Let's imagine that we know that we're going to need to borrow at time T. So here we are at time zero. And we're going to need to do an S period loan at time T in the future. And so naturally, if we know we're going to need this loan, we have some rate risk. If interest rates are high, that loan is going to cost us a lot of money. If they're low, it'll cost us less money. So we have some risk at time zero to this loan. So what we can do is we can go long an FRA on whatever notional amount that we plan to borrow, say L. And what we know is that at time T plus S, we're going to get a payment or make a payment, depending on the prevailing rates, that's equal to L times the difference between the prevailing rate and the forward rate at time zero. That's going to be a payment. That's an inflow. It could be an outflow if RT is low. On the other hand, we know at time t, we're going to do a loan of L, and at time t plus s, we're going to have to repay L times 1 plus RT, right? It's logical that at time t, we're going to do a loan at the prevailing rate, RRT, and at the end of the period, pay the loan plus interest. Now, if you look at the forward rate agreement, which is an inflow or an outflow, depending on whether it's positive or negative, and the loan payment I make at the end of the period, and add them up, you see that I always on net pay L times 1 plus R0. In other words, a forward rate agreement, if I know that I'm going to make a loan at time L, or an investment at time T, I said L. Let me start again. Dave, I'm starting again. If I know that I'm going to make a loan at time capital T, by doing a forward rate agreement, I can guarantee that a loan I take will be, in fact, done on net at today's forward rate. Similarly, if I wanted to make an investment at time t in the future, and I would go short this forward rate agreement instead of going long to reverse the sign, I could assure myself that I could invest at today's forward rate. So this is how forward rate agreements can be used to hedge. Now notice they're not options, because in fact it could well be that the prevailing rate at that time is quite low relative to today's forward rate, but you're locked in, and in a sense what we've done is to decide at time zero that we're happy with today's forward rate, and whether rates are higher or lower in the future, we're willing to trade those events off and settle for today's forward rate. In a sense, this is like doing a futures contract. This is indeed a futures contract on an interest rate.